block diagram shows the key stages of digital image processing. Here we could see the problem domain is being occurred by the image acquisition block. Here it represents the problem domain means the object of interest, which what we want to do the further, take into further process. Then comes the image enhancement. So here, so we could see the problem domain is being occurred by the image acquisition system. This diagram shows the image object of interest is being illuminated by a source, and it is captured by an imaging system, and how it is stored as a digital image, the 2D version of the image. Then it could be acquisition could be simple as being given an image which is in digital form. The main work involves scaling and color conversion. If it is a color image, it has to be converted from RGB to grayscale. Then comes the image enhancement block. The main focus of this block is it is amongst the simplest and most appealing in areas of image processing. It is also used to extract some hidden details from an image and is subjective. Normally, enhancement means a poor quality image is being improved with the high quality. So that has been shown here. Next comes the image restoration block. It deals with appealing of an image, but it is objective. Restoration is based on mathematical or probabilistic model or image degradation. So here we can see an image, some like Mars or some image. In that it is not clear, so that the image has been restored. It is been the quality is being improved. Any error or problem, any distortion in the image is being removed and restored. We have just restored the original quality. And next comes the morphological processing. It deals with the tools for extracting image components that are useful in the representation and description of shape. Sometimes some minute information alone we have to take it into account and process further. So in order to do that, we will be extracting the some image components alone. Those kind come under the morphological processing, like thumb impression. From that we will be taking the biometric, and in that we will be taking the we will be combining the two image, like A plus A union B, A excluding this, like using set theory we will be dealing the images. So those calculation has been given here from using the set theory formulas. We have been it has been described. So when we combine two images, we will be getting the additional improvement in the quality and additional information from the two images that will be tuned, and it will be shown in the final output image. Next comes the segmentation. It includes the partitioning of an image into its constituent parts or objects. Autonomous segmentation is the most difficult task in image processing. So here we can see the image segmentation in the sense this 3D view is been, we have been the segmented the tools part alone and shown in the next image. Its corresponding histogram is being shown here. Histogram, it means the gray level, frequency of gray level in the image. Frequency of occurrence of gray level in a particular image is called histogram. That is being shown as a 2D image in the lines form. So here you can see that the difference between the two images here is that shadow is being removed here. So we have segmented only the image. Without its shadow, we have segmented it. Next comes the object recognition and recognition. Detection and recognition, we can combinedly say. It is a process that assigns a label to an object based on its descriptor. So here it's iris recognition. Iris, you can see here. So they have mentioned here as a some, for example, particular image for petal length and petal width they have given. So particular part alone being it is shown, it is marked. It means that the object is being detected. Particular thing alone we want to take from the original image. For example, if it is a garden image, in that we have to detect only the petals of a particular flower. So they have given like this. So they have been frequently occurred, and their occurrence is being calculated, and as a number we could see how many times it has been given. So petal length and petal width is being specifically, and it is shown here. And next comes the representation and description part. Here the 2D image captured is being shown, is stored as in a digital image. And next block we are taking only the particular object of interest. Under the dots alone we have captured that shape. And next we can specifically we can find the shape and its range. And next comes the uh, range with the value. So this is it follows an output of segmentation stage. Choosing a representation is the only part of the solution for transforming raw data into a processed data. So this is, we can say, as a final block of the diagram. And color image processing and image compression is been as an optional case. Sometimes we need to use the color image processing block. Sometimes we have to use the image compression block. Image compression block is nothing but when we want to send the image in a compressed form. When we want to save the size of the storage space, then we have to compress and send the image for a particular case. In those cases, we will be using the image compression block. Next comes the image compression. It involves the developing some functions to perform this operation. It mainly deals with image size or resolution. We could see this image PNG and its corresponding size. So what is this is, when we want to reduce the size, we'll go for the image compression block. Okay, then comes the color image processing. It deals with the pseudo color and full color image processing. Color models are applicable to digital image processing. We can say some of the color models as RGB, HSI, YUV, like that. So this is the color image processing is also an optional one. When we want to do directly, we can do it directly with original color component. Otherwise, we can convert into grayscale and perform the further processing. Here it shows, the slide shows some of the applications. Image sharpening and restoration, where we will do, when we want to do the zoom, blur and sharp and edges, we will be doing this process. In medical field, we can see here remote. So in remote sensing, UV imaging, transmission, many different formats for high and low bandwidth to encode and transmit. In machine vision, it's a challenge to increase the vision of the robot. Color image processing, pattern recognition, and some particular lost data. We want to capture only the handwriting of a particular famous freedom fighter or some other personality. We want to take only the handwriting of those. That can be done with the help of image processing with pattern recognition. And video processing, noise reduction, detail enhancement, motion detection, frame rate conversion, aspect ratio, color space. So microscopic imaging, everything is there in the many application it has. And in future we can see some of the research scope for the image processing is like computer vision, AI, computer graphics and multimedia and animation. In AI, we can nowadays we can say deep learning, machine learning applications are done with the help of a image processing. Thank you.